Hello everyone, welcome to Power System Protection course. Myself Kubera U, working as Assistant Professor, Department of EEE, SJBIT. In this lecture, I will discuss about types of faults and zones of protection. First, we shall see the types of faults. So, let us first understand what is fault. So fault means any abnormal condition that occurs in the power system we treat as faults. So these faults are broadly classified as into two types. One is symmetrical faults and unsymmetrical faults. So these faults classified based on the power system condition. So whenever the faults, some faults occurs on the power system, if the power system is in still a balanced condition, then that fault is said to be symmetrical faults. If the power system is unbalanced condition upon the occurrence of the fault, then that fault is called as unsymmetrical fault. The example for symmetrical faults are three-phase short circuit and three-phase to ground faults. So in if there is a three-phase short circuit, the effect will be same on all the three phases of the power system. So this power system still will be under balanced condition, so it is called as symmetrical faults. Unsymmetrical faults, so the example for unsymmetrical faults are line to ground fault, that is single line to ground fault, double line fault, double line to ground fault, open conductor faults, either it may be a one conductor open fault, two conductor open fault, winding faults, and simultaneous faults. So under unsymmetrical faults, the power system will be under unbalanced condition. There will be unbalanced condition. There will be changes in the magnitudes of the voltages and the phase angle between all three phases. So under this, these faults are called as unsymmetrical faults. Line to ground fault means it is a single line. Uh, Single line connected to the ground. Double line fault, that is two lines getting short circuited, double line to ground, double line two lines getting short circuited and connected to the ground. Open circuit faults, the open conductor faults, that is one conductor open fault, two conductor open faults, and winding faults which may occur in the uh, transformers or any electrical machines. Simultaneous faults means one or two unsymmetrical faults occurring simultaneously. One or two unsymmetrical faults occurring simultaneously. Example for simultaneous fault is if suppose there is a one conductor open fault, at the same time the open conductor may touch the ground, that will become a line to ground fault also. So two faults, that is open conductor fault and as well as a line to ground fault, both are occurring simultaneously, so this we can treat it as simultaneous faults. So this is about the types of the faults. Now we shall see the effects of these faults. Effects of these faults. So the most dangerous type of fault is a short circuit fault. So whenever there is any faults symmetrical faults or unsymmetrical faults, the it causes this short circuit. It causes this short circuit. Either it may be a line to ground fault, line to line fault, double line to ground fault, or symmetrical faults, that is three phase fault or three phase to ground faults. The most severe type of fault is the three phase fault, and these short circuits has the following effects on the power system if it remains uncleared. If the fault is not cleared in the power system, it affects the power system. So first one is when there is a short circuit, there will be heavy currents which are flowing in the power system, which may cause damage to the equipment or the other elements connected in the power system. So due to the heavy currents, it will damage the power system equipments, and due to these heavy short circuits, there may be a fire hazards there may be fire hazards, and these fire hazards may destroy the elements of the power system, that is generator, transformer, transmission lines, etc. So there is also a possibility that the fire may spread to the other parts of the system. And due to faults, there may be a reduction in the supply voltage of the LD feeders, and this will result in the loss of the industrial loads. And due to faults, there may be a cause of unbalancing of supply voltages, as that is the unbalancing condition of the power system. Thereby, due to these fault currents, there may be a heating on the rotating machines. The rotating machines may get damaged, and there may be a loss of the system stability. So one of the major concern in power system is stability. So due to the occurrence of these faults, there may be a loss of the stability, and the individual generator in the power system may lose its synchronism, resulting in a complete shutdown of the power system. And these all faults may cause interruption to the supply to the consumer. So this is one of the major factor. Any faults that occurs in the power system, that finally affects the consumers, so thereby causing the loss of revenue to the power supply companies. So these are the effects of the faults that occurs on the power system. Now let us look at a few statistics about the faults. So this table shows the percentage of distribution of faults in the power system on various elements. So here we have elements and percentage of total faults. In overhead lines, the occurrence of the faults is around 50%. So 50% of the faults occurs on the overhead lines. Underground cables, it is 9%. Transformers, it is 10%. Generators, it is 7%. On switchgear equipments, that is CTPT relays, it is 12%, and control equipment and etc., that is 12%. So major 50% of the faults occurs on the overhead lines. Now we will see the frequency of occurrence of different faults on the overhead lines. So we know that already the 50% of the faults occurs on the overhead lines. In overhead lines, there are different types of faults. Line to ground fault, we call it as LG fault. The percentage of occurrence of this fault, line to ground fault, is 85%. So we can see that the maximum amount of faults that occurs on the overhead lines are line to ground fault, and line to line fault, it is 8%. Double line to ground fault, it is 5%. And three phase, the most severe fault, it is very rare, it is only 2%. So this is about the types of the faults, and faults effects, and faults statistics. Now we shall discuss zones of protection. So we know that in the power system there will be different many equipments like generators, transformers, transmission lines, distribution lines, right? So every equipment in the power system should be protected. Every equipment in the power system should be protected separately. Should be protected separately. So in order to do so, we divide the power system into number of zones. We divide the power system into number of zones. So in each zone there may be at least one or at most two power system components are protected. In each zone, one or at most two power system components are protected. So here you can see this dotted lines. This is a picture of the zones of protection, and this is a single line diagram of the power system. So we can see here, this is the generator, this is circuit breakers, switch gear, and here we have bus bar, bus couplers, transformer, transmission lines, bus bar again. So okay, so we have the generator here. So this dotted lines represents the zone of protection. This is one zone of protection. So in this zone we can see here the generator is protected, and as well as circuit breaker is protected. So similarly we have one more zone here. In this zone, the high voltage switchgear protection, that is circuit breakers, are protected here. And here you can see one more zone, that is here we are protecting the transformers and circuit breakers. So this becomes one zone. Similarly, here there is one zone, here there is one zone which is protecting the transmission lines and the circuit breaker. So there will be a these zones of protection covers all the equipments in the power system, covers all the equipments in the power system. So all the zones are always overlapped with each other. You can observe here, this is the generator production zone. So here this zone is in overlap with the HV production HV production zone, right? So this is because if there is no overlap, then if any faults occurs at the boundary of the zone, let us say if there is no overlap here, if the fault occurs at the boundary of the zone, then the protective system may fails to detect whether the fault belongs to its zone or not. So then the protection system may not work effectively. In order to avoid that, the all the zones are overlapped with each other. So if the primary if one zone is fails to operate, the other zone, the overlapped zone, will come into picture and will protect the equipments in the power system. So here we can see we have different zones: generator production zone, HV switchgear production zone, transformer production zone, EHV switchgear production zone, transmission line production zone, and similarly EHV extra high voltage switchgear production zone. So this is about the zones of productions in the power system. That's it in this lecture. Thanks for watching.